Hello guys, hope you guys are doing alright. Sorry if there's any extra sound that you guys can hear. I guess my apartments are doing landscaping today. But okay, so we're gonna be going over complex fractions today. Okay, now you might have heard the word complex before in math. Whenever you start referring to imaginary numbers mixed with real numbers, complex fractions are not that actually. Okay, complex fractions are going to be your worst nightmare, actually. Or maybe your worst nightmare in math. But we're going to try to get through them. That way you guys can become pros at this. Okay, so complex fractions are actually kind of like an inception of fractions. Okay, let me show you an example of what I mean. They're fractions within fractions. So right here, we have a fraction bar. And then right here we have a fraction, right here we have a fraction. Right here we have the same thing. Fraction bar, well, fraction bar right here, and then fraction, fraction, fraction. Okay. So one of the these two questions actually were actually taken away from one of the reviews I was sent for the final that HISD is going to give, or the final that HCC is going to write. So I thought we should probably go over this before you guys take it. That way you guys have no surprises. Okay. So complex fractions. What do you want to do here? Like how do you simplify this? Well, in order to simplify it, or in order to know that you've had it simplified, that it's simplified completely, there's two things that you want to do. Okay. You don't want to have a fraction as part of the numerator or the denominator. So once it's fully simplified, if you still have a fraction, then you still have more steps to do. Okay, and then if possible, all factors should be cancelled out. Excuse this redundant term right here, or statement right here. Okay, so if possible, all factors should be cancelled out. What do I mean by that? Well, if you have 2 times x plus 1 divided by x plus 1 times x plus 3, because you have x plus 1 on both the top and the bottom of that fraction, okay, you should cancel those out. Those factors should be cancelled out every time. Therefore, your answer here, once it's fully simplified, would be 2 divided by x plus 3. Okay, notice that I took off the parentheses here, because at that point, x plus 3 is the only term. So whether you see the parentheses there or not, you know, just think about it as being invisible. Okay. but they're the same thing. All right. So before we go off and start doing some of these questions that HISD gave us, and that I'm gonna give you through Delta Math, what should we first learn how to do? Well, we're dealing with fractions. We're dealing with fractions inside of fractions. A fraction is just another way of saying division. Okay, so whenever I say 1/3, that's the same thing as me saying what's 1 divided by 3. Okay, these are the same exact thing. If you never thought about it that way, well, you're learning something new every day. All right. So divide fractions. Let's say we had something like these two questions right here. So what do I do here? Well, 2 divided by 3 over 4 over 5. 4 divided by 5. Well, let me go ahead and write that down like this instead. Okay. Divided by 4 divided by 5, or 4 over 5. Okay, so these two fractions I've divided. Whenever you're dividing fractions, it's actually really just multiplying fractions. Here's how you do this. You're always going to take the second equation, or the second fraction, sorry. Second fraction. And you're going to flip it over, meaning that whatever's at the bottom goes to the top, and whatever's at the top goes to the bottom. Okay. And that's going to be 5 divided by 4. Okay, now once you do that, you're going to go ahead and change that division sign into multiplication sign. Okay, at this point, things should be easier for you. You should know how to multiply fractions. Okay, if you don't, all you have to do is take the top numbers and multiply them together. 2 times 5 is 10. And then take the bottom values and multiply them together. 3 times 4 is 12. Okay, after this, if you need to simplify further, then just go ahead and do so. So we had 10, we had 12, they're both even values, so I can divide by 2 on the top and the bottom. So this is going to be 5 over 6. At this point, 5 is a prime, so I can't really factor that out any further. So meaning that this is actually fully simplified. And sorry if you can catch that, but I assume that you guys know how to simplify fractions at this point. Alright, so the next one, 7 divided by 8. Okay, and even though we have parentheses, it doesn't matter whether we have the parentheses or not. You know, it's still going to be the same type of question. 7 divided by 8, and then 9 divided by 8, divided by 9 divided by 8. Okay, so what do I do here? You do the exact same thing. You take this expression, or that fraction, and flip it over. So that's going to be 8 divided by 9. I'm going to have 7 over 8 on the same spot. And then I'm going to multiply. Okay. You can have some shortcuts too if you want, like right here. You see how we have 8 and 8 here? We can go ahead and factor those out already. So 8 divided by 8, they cancel each other out. But then we have 7 divided by 9. 7 goes at the top, 9 goes at the bottom. Okay. That's our fraction right there. Okay. And it's just because we had the same thing here as we did here. We could have done that up here too, to help us simplify the problem. You see how we have 2 up here, we have 4 down here. Well, 4 is actually just 2 times 2. So if I wrote it down like that, and I just cancel out one of the 2's, I could have just multiplied across that way. So 5 times nothing is 5. 3 times 2 is equal to 6, so we actually get 5 divided by 6. Simplified already. Alright. Let's do one more, because I'm sure some of you guys already know how to do this, and you're probably tired of watching this video. Okay, so let's take a look at this number. We have 45 divided by 7 divided by 3 over 2. Okay, remember the fraction bar just means it's the division. So this is like 3 divisions in one. So what we're going to do is, again, take that second expression, or second fraction, and we're going to flip it over. So instead of having 3 over 2, we're going to have 2 divided by 3. Okay. We're going to have 45 over 7 over here. And then if you think you can simplify at this point, you can go ahead. 2 and 7 don't. 2 and 3 don't simplify. But 45 and 3, I think, do simplify. Let me see. Oh, 45 is 3 times 15. Okay, 3 times 15. We can cancel out this one. We can cancel out this one. We get 30 over 7. 15 times 2 is 30. 7 says doesn't multiply onto anything, so we get 30 over 7. That's our final answer. I'm not going to simplify this any further, or I'm not going to change it into a mixed number, because, you know, fractions are okay. You don't really need to change them into decimals all the time. Okay. If you're still having trouble with decimals, I mean by turning them into decimals, you know, it's likely a better option to just keep them as fractions anyways. Alright, so now let's go ahead and look at this this problem where we had to simplify the complex fraction. Well, first thing you want to do is take the whole numbers and turn them into fractions to begin with. Okay. We're going to turn this top side, 1 divided by a plus 1, into a sum of 2 fractions. 1 divided by a plus 1 over 1. Okay, why am I doing this? Why am I making more fractions? You might hate that. Well, it's because we've already gone over how to do how to get fractions. How to add fractions. Sorry. Okay. And all we had to do was take the denominator from the bottom here and multiply it onto the top and bottom over here. So we have 1 divided by a, and we're going to take 1 and 1 over here. And this numerator and denominator are going to get both get multiplied by a. And this numerator and denominator are both going to get multiplied by 1. Okay. So 1 times 1 is 1. And then we have 1 times a, which is a. And then our denominator is just going to be the product that we get from doing this once, doing the denominator once. So that's going to be a. Okay, so that's going to be the top of the fraction. Okay, now we're going to do the same thing for the bottom of the fraction. We're going to take that 1 divided by a subtracted by 1, and we're going to turn the 1 into a fraction, 1 divided by a minus 1 over 1, and we're going to go ahead and make sure that they have the same denominator. That way we can have a fraction at the bottom. Okay, so we have, I'm going to go ahead and multiply this by 1 and this by 1. I'm going to multiply this by a and this by a. Remember, this one goes to this one, and this one goes to this one. Okay, so 1 times 1 is 1, and then we have minus 1 times a is a, and then below it 1 times a times 1 is a. So these are the two fractions that we are going to go ahead and divide. 1 plus a divided by a, division 1 minus a divided by a. Okay, to follow along suit just like we had earlier, I'm going to go ahead and take the second expression, the second fraction, and flip it over. Okay, now change the division sign into a multiplication sign, and if you can, factor stuff out. Okay, remember what I did here with the 8s. Since we had one at the top, we had one at the bottom. What do you think I'm going to do with these a's? Well, they're going to get cancelled out. What's going to be left? This is 1 plus a divided by 1 minus a. Okay, I can't factor out that 1 plus a any further. I can't factor out that 1 minus a any further because these are linear terms. Okay, so unless I can factor out a number, which I can't because there's a 1 there, then they stay the same. Okay, now let's go ahead and look at that second problem from that review. This one right here. I'm going to do the same exact thing as I did earlier. I'm going to have 4 over 1 plus 2 over x. I turned that 4 into a fraction. Okay, this is because I want to take that fraction and make sure that they have the same denominator. So I'm going to multiply by 1 here. I'm going to multiply times x here. And that goes to the top. And this one also gets multiplied by 1 at the top. Okay. Therefore, our fraction at the top, our new fraction, is going to be 4x, 4 times x. And then 2 times 1 is 2. So it'll be 4x plus 2. Okay. And at the bottom, we're going to have x times 1. So x. 1x if you want to write it down, but not necessary. Okay. For the bottom, we're going to do the same thing. We're going to take x over 3 plus 1 over 6. I'm going to take this number and multiply it by, let's say, 6. By the way, if you have shortcuts to use, or you know how to do this in an easier way, you can go ahead and do that. Okay, this is for mainly the people who didn't know how to do this before. Okay, so do it in your own way. If you still get the same answer, awesome. You've got it. But for those who don't, you know, try it this way. Just follow along. Hopefully everything gets done right, and then you'll be able to do all your questions. Alright, so here by multiplying 6 times x we get 6x. By multiplying 1 times 3 we get 3. And then your denominator is going to be 3 times 6, which is 18. Okay, so our top was actually, let me erase that part. Sorry about this. Alright, so we have 4x plus 2 divided by x, division, because remember we have a fraction bar, that's what it means, 6x plus 3 divided by 18. Okay, so I'm going to do something a little different this time. Okay, because we've been factoring pretty recently, I'm going to do some factoring before I start dividing here. Okay, so right here what I've noticed is that that 4 and that 2, at least to me, I can notice it. I can factor out a 2 away from it, meaning that that 4 is divisible by 2 and that 2 is divisible by 2. Now, by taking out that 2, I have to divide both of these numbers by 2. So that's going to be 2, that's going to be 1. I'm going to leave the x alone because I'm not factoring out an x. So we have 2 times 2x plus 1 is actually equal to 4x plus 2. So I can scratch this part out. Okay. Now for the second one, I can do the same thing. I have 6 and 3. They have a common factor of 3. Because 6 is divisible by 3, 3 is divisible by 3. So now that I factored out at 3, what I'm going to do is I'm going to divide the 6 by 3, which is 2. I'm going to divide the 3 by 3, which is 1. And leave everything else the same because I'm not factoring out any x's. Now, 3 times 2x plus 1 should be 6x plus 3 whenever you distribute it. Therefore, I'm just going to go ahead and scratch this out and leave it as this. Now I can go ahead and start dividing. First step is take the second expression or second fraction and flip it over. That means that 3 times 2x plus 1 goes at the bottom. And the 18 goes at the top. I'm going to change that division sign into a multiplication sign and then keep the first fraction the same way. Okay, meaning I don't flip that one around. Okay. Now that I'm multiplying, if I see the same number on the top and I see it at the bottom, then or expression, try to factor it out right away. Like right here and here. Okay. So we have 2 times 18, which is 36, divided by x times 3. Now, one thing I can notice here is that 36 is a multiple of 3. Okay, 12 times 3 is the same thing as 36. So I can go ahead and factor that out so that I can cancel out the 3's. Okay, so now x times 3, or 3x, the 3's cancel out, and we get 12 over x. So that's our final expression. This is a simplified complex fraction now. Okay. Now, you guys need a bit of practice. Okay. I'm going to give you guys an assignment on Delta Math. Hopefully, some of you guys have already seen it. Okay. Hopefully, after this video, you guys are able to do it on your own. But in case you need any help, please let me know. I can set up some video conferences so that you guys can get your work done. And sorry, voice crack. Or I could just help you with minor things if you think just one text message or something would suffice. Alright, so now let's look at some examples that are going to be on Delta Math. Okay. Here we have the problem. Fully simplify 1 plus 5 divided by x. And then division, x plus 8 divided by 15 plus 1 divided by x. Okay, so this is similar to the second problem. Alright, so this is what I'm going to do. I'm going to take the top of the fraction, 1 plus 5 divided by x, and I change it so that the 1 is a fraction. And then I want them to have the same denominator. So I'm going to take this denominator, and multiply it onto the other fraction, both the numerator and the denominator. So that x gets multiplied over here and here. And this 1 gets multiplied over here and here. Okay. The denominator is going to be the same for your result. So x times 1, which is just x. And then on top, we're going to have 1 times x, which is x, and plus 5 times 1, which is 5. These are being added, so it's going to be x plus 5 at the top. Okay. Now at the bottom, we do the same thing. That denominator over here, we're going to try to match the denominator so that we can add them, and then at the end, we're going to go ahead and divide those two fractions. Okay, so x plus 8 divided by 15 plus 1 divided by x. So what we're going to do is we're going to take this term and we're going to take it multiplied by the denominator over here, 15. Both the top and the bottom. Then we do the same thing for this fraction. We're going to take both the top, numerator and denominator, we're going to multiply them by x. Okay. Now, because we have more than one term here, I'm actually going to put parentheses around it because this indicates that I'm going to have to distribute. Okay, I didn't have to do that for the other ones, but I do here because it's two terms. Okay, so x times x is x squared. X times 8 is 8x. Oh, and then let me do the denominator first before I do this side. X times 15, 15x. That's it. And then we do plus 1 times 15. Well, that's going to be plus 15 then. because 1 times 15 is 15. You're adding it. That's it. Okay. So we're going to take x plus 5 divided by x, and we're going to divide it by x squared plus 8x plus 15. So I'm going to do that over here. 8 plus 5 divided by x. I'm going to put that into parentheses because this kind of looks like a factor. So I might be able to factor out in x plus 5. And then we're going to have division. X squared plus 8x plus 15 divided by 15x. Okay. Alright, so I'm going to put these x's in parentheses as well, just because I feel like those are going to get factored out. Okay, you don't have to do that yourself, but whenever you see it, it might help. Sometimes it might not. It's up to you. Okay. Now, notice that we also have x squared plus 8x plus 15 here. Just recently, we've been factoring things out. So how about we see if we can actually factor this out? X squared plus 8x plus 15. I take the 15, because there's no number right here, it's a 1. So I'm going to take that 15 and write down its factors. You have 1 and 15, you have 3 and 5, and I think that's it. 1 and 15 add up to 16, 3 and 5 add up to 8, and hey, look at that. That 8 is the same 8 that we have right here. So these are actually going to be part of our factors, 3 and 5. So x plus 3, x plus 5. We can actually take these two numbers and factor them out into that. The weird how like the things we've been doing lately coincide with the things we keep doing in the future, right? Alright, so I could write it down as x plus 3 times x plus 5. Awesome. And then I'm going to divide, meaning that I'm going to take this fraction and I'm going to flip it over. So x plus 5 divided by x. I'm going to change that division sign into a multiplication sign, and then I'm going to flip that fraction around. So 15 times x goes over here, and x plus 3 times x plus 5 goes over here. And remember, I'm going to leave those parentheses on this one because it's a factor, and I think that the x's are going to cancel out, which they are on the bottom. So I left that parentheses around it. Alright, let me change color because sometimes it can get boring. Okay, so I have x here and x here, so I can cancel those out. And I have x plus 5 here, and I have x plus 5 here, and I can cancel those out. So now 15 doesn't get multiplied onto anything, so it stays the same. And then x plus 3 doesn't get multiplied onto anything, so it stays the same. And that's our final simplified, fully simplified complex fraction. Yeah. Alright, so I think we still have time for one more. Video's not too long, so let's do one more. Okay, so let's say we had something like this. Okay. I'm going to take that top of the fraction, I'm going to do the same thing as before. See if I can make the 1 into a fraction, which I can, just by dividing by 1. And make sure that they have the same denominator. Okay. To get the same denominator on the bottom here, I have to multiply by x squared on both the top and the bottom, and then here I have to multiply by 1. Just basically exchange this denominator to this side, this 1 to this side. Okay, so whenever you add or subtract these, the denominator is always going to be the same thing as the product of just one of the fractions. So that's going to be 1x squared or just x squared. And then I take the top, and I guess I do whatever is in the middle to the second, minus the second value. Okay, so 1 times 25 is 25, minus x squared. Okay. Alright. Alright, and then we're going to do the same thing for the bottom values. So we have x minus 2 divided by 15 minus 1 over x. I'm going to take that x and multiply it on both the top and bottom here. And I'm going to take the 15, I'm going to multiply it to both the top and the bottom over here. Oops, sorry about that. That should be a 15. Okay. And then x times 15 is 15x. X times x. Well, make sure that you distribute here. Two terms, remember. So we get x squared minus 2x. And then right here we have minus 1 times 15, which is minus 15. Okay. So we're going to be dividing these two fractions. 25 minus x squared divided by x squared. And then we're going to divide by x squared minus 2x minus 15 divided by 15x. Alright. So let me change colors again to red. Alright, so what I'm noticing here is that we could probably factor some stuff out. Okay. First of all, this x squared minus 2x minus 15, those numbers seem too familiar to me, so I'm going to go ahead and do that first. You can obviously do this as you like, in whatever order you like. The only time where order does matter is whenever you're using PEMDAS, because it's order of operations. Alright, so we have a 1 in the front, meaning that I only look at the back number, negative 15. I'm going to ignore the negative and just look at the factors for now. That's 3 and 5. And then that's it. We want them to add up to a negative 2. But remember, we need a negative 15 product. So because I want a negative number whenever they add up, I'm going to take the bigger numbers and make those negative. 1 minus 15 is equal to 14, negative 14. And 3 minus 5 equals negative 2. So these are going to be part of our factors. X plus 3, x minus 5. So I can replace these with those factors. Okay. And now that I know these factors are here, I have a feeling that x minus 5 or x plus 3 are going to be over here too. Okay, so let's go ahead and take that. 25 minus x squared. I kind of want to change this up. How about if I made it negative x squared plus 25? Okay, and now that we have that, how about if I took the negative 1 and factored it out? Okay, negative 1 and then times x squared minus 25. Now I factored out a negative from the 25, meaning that the positive turns into a negative. Okay, and now I can do the same thing as before. We have a 1 right here. We have a negative 25 at the end. And I'm just looking for numbers that match the one in the middle. Since there's no number in the middle, that means it's a 0. So we basically want to cancel out the numbers. The factors of 25 are 1 and 25. And then 5 and 5. Because it's a negative 25, one of them has to be negative. I want it to be 0, so it doesn't matter quite which for now. But hey, look at this. Negative 5 plus 5 equals 0. So our factors here are negative 1 times x minus 5 times x plus 5. So I'm going to go ahead and replace this over here. Okay, and now I'm going to divide. Sorry it took so long for this one. This one, I will admit, is a harder problem than the other one. So let's see. Negative 1 times x minus 5 times x plus 5 divided by x squared. I'm going to write that down as x times x. Okay, just because it might make it easier for me later. Alright, now the second part, the second fraction, I'm going to go ahead and flip. Okay, the division sign changes into multiplication sign, and then the top goes to the bottom goes to the top, and we get 15x at the top. We get x plus 3 times x minus 5 at the bottom. Okay, well, look at that. X minus 5 cancel out. This x and that x will cancel each other out. And that seems like it's it. Okay, so we have negative 1 times x plus 5 times 15. So I'm going to write it down like this instead. Negative 15 times x plus 5 over here. And then we have x plus 3 at the bottom. And, well, that's not really quite simplified, so I'm going to go ahead and multiply the negative 15 and distribute. Sorry if you needed this, but just pause the video and go back. I just need some extra space for my final answer. Okay, and now this is the last example I'm doing, but if you need any more, please just let me know. You know, these problems can get really hard, especially if you're trying to learn them on your own. And I know that a lot of you guys don't have that working habit just yet. And you know, I'm happy to help you guys if you need it. Negative 15 times x is negative 15x. Negative 15 times 5 is going to be minus 75. And then we have x plus 3. That's our final answer for this one. And I guess we'll call that the end of the video. Hope you guys are doing fine. And until the next time, goodbye.